Hey guys, welcome back to another video lesson. Trying out a new angle here, sitting at a different spot at my table, so super exciting. Today we are talking about spheres. We are going to be talking about volume and surface area of spheres today in one lesson, so that's really exciting for us. When you picture a sphere, you probably picture like the earth or a basketball or anything like that's just a three-dimensional circular object. So something that I want to talk about is a net of a sphere. If you picture a cutie or like a little clementine, to find the surface area of that or the net of that, it would actually be, if you peeled that, it would be all of the peel. So that's something you can visualize. If you picture you are getting a basketball for Christmas and you wanted to wrap all of that, that would be the surface area. The wrapping paper would be the surface area. So when you actually unfold it, it looks something like this that we've got up here, or for great circles. The great circles are just like the circle that go through the center of the sphere, and that's just the surface area. It's just equal to the surface area. So if you're curious about where the formulas that we have come from, you can watch either of these videos. They're linked in the guided assignment that's linked on this assignment page. So feel free to watch those. But key things to note are just the surface area of a sphere is, surface area of a sphere is 4 pi r squared. So that's for surface area. And then the volume of a sphere is 4/3 pi r cubed. And that is basically derived from the fact that one sphere holds the same amount of volume as 2/3 of a cylinder that has the same height and radius as the sphere. So when you look at this equation right here, it simplifies to 4/3 pi r squared. That should be a cubed. Sorry, 4/3 pi r cubed. That is the formula for volume of a sphere. All right, so let's talk about this. Still, you want to identify any like key information that you need. So in our first example, we are given a sphere and automatically we're just given our radius is equal to 3. And this, for these formulas, all that you need is the radius. So to find the volume, I am just going to say 4/3 pi times my radius, which is 3 cubed. So I'm just going to enter this into my calculator, and I've got 4/3 times pi times 3 to the third power. And I get that my volume is equal to 113.10, and this will be cubic units. Then for surface area, volume is equal to 4 pi r squared. My radius is 3 times 3 squared. So 4 times pi times 3 squared gives me, crazy, the same thing. So I don't know why I wrote V here. This should be CSA. Sorry. SA. So my total surface area is equal to 113.10 square units. And it just happens to be the case that when you have a sphere with a radius of 1, the volume and the surface area will be equal. That's not always going to be the case, which we will find out in example 2. In number 2, I am given that my diameter is 20, which means that my radius is equal to 10. So my volume is equal to 4/3 pi r cubed, so 10 cubed. So I enter this all into my calculator, 4/3 times pi times 10 to the third power. So I get that my volume is equal to 4,188.79 cubic units. Because I'm in volume, it's cubic units. Then for my surface area, that would be equal to 4 pi r squared. So 4 times pi times my radius is 10. I want to square that 10. So 4 times pi times 10 squared, and I get surface area is equal to 1,256.64 with rounding square units. Okay, a way that I remember how to apply the formula when I'm talking about volume is always cubic units, so I'm cubing my radius. Surface is always square units, so I am squaring my radius. All right. This next one is a little bit tricky because it is a semisphere. It's or a hemisphere. Sorry. So it is half of a sphere. So to find my volume, I am going to take my 4/3 pi times, in this case, my radius is equal to 9, times 9 cubed. If this were a full sphere, that's what I would do. However, it is not a full sphere. It's half of one. So I'm actually going to take this entire thing and divide it by 2. So I'm going to take 4/3 times pi times 9 to the 3rd power. So if it were a full sphere, my volume would be 3,053.63. Right? But then it's not, it's only half of that, so I have to take that answer and divide it by 2. So my volume is equal to 1,526.81 cubic units. And then for my surface area, I've got to do some things to fix this up as well. So my surface area is going to be 4 pi times my 9 squared. Now, that would give me the full surface area, but once again, I've only got half of that, so I'm going to divide it by 2. But now if I think about this, this figure over here, if I actually wanted to cover that in wrapping paper, right? Because that's what, when you think about surface area, thinking about covering it in wrapping paper. So if I wanted to actually cover this in wrapping paper, I have to cover the round, like curved side, but then also I've got that base, right? Like this base, that circular base that's like shaded blue in the picture. So I need to cover that as well. So I'm going to take this that I've got already as part of my formula, but then I have to add the area of one of those circular bases. So my base is a circle, the radius is 9, and area of one circle is pi r squared. So I'm going to add plus pi times 9 squared because that would give me the area of the base. Okay, so I've got 4 pi times 9 squared divided by 2. So this first part is 508.94 plus, I'm going to do pi times 9 squared, which gives me 254.47. Okay, so those are my two parts. So I add them together, and my total surface area is going to be 508.94 plus 254.47 gives me 809.94 square units because I am talking about surface area. Okay, so that is all I have for you today. Spheres, super exciting. If you have any questions, comments, concerns, feel free to email me. If you just are like, oh, Miss Leverson, look, I know what a sphere is. Just send me a picture of a sphere you found around your house, okay? All right, stay safe, wash your hands, and enjoy the rest of your day. Bye, folks.